In this video, I'm going to discuss the covalent bond model, which basically involves the sharing of electrons between atoms. And again, let's define the definition of a covalent bonds. Covalent bonds are basically those that are formed by the sharing of electrons between atoms. And it turns out that the orbitals of different atoms overlaps in order to produce that bonds. So we see that ultimately the electrons locate on the orbital of an atom. So two different atoms will then take the electron from the orbital and overlap them together, and that's what produces the covalent bonds. And covalent bonds exist among nonmetal. For an example, let's say we have an atom A, and now atom A has an electron on its orbital, and interacting with an atom B, and atom B also has another electron on its orbitals. And in this case right here, A is a nonmetal, and B is also a nonmetal. And because both of them are nonmetal, they both want electrons to have an octet of electron. So therefore, there's none of the atoms that like to give electron away. And this is why that they do not transfer electron like what we have seen in the case of an ionic bond, because they both want electron. But if they were to stick with the amount of electron that they have and not do anything about it, then this atom right here are not stable to exist as individual atom. So therefore, one way for them to also have an octet of electron without giving the electron away would be to do the following. Let's share the electron. That's what these two atoms would be doing. So when atom A, it take an electron and share that with the atom B, the orbitals of these two atoms right here will be overlapping together. And now the two electrons that they have will be shared between them. And that produces that bond right there. So molecules that are produced by covalent bond are then called covalent molecule or covalent compound in case it happens to be a compound, or a molecular compound. So those are some of the terminology that we can use to describe chemical substances that have covalent bonds between them. And notice the following. Electrons, the electrons that are shared between the two atoms, and we call that a bond pair. A bond pair is basically a pair of electrons that have been shared between two atoms. Then both of those electrons can be claimed by both of the atoms toward counting their octet of electron. And therefore, this allows each individual atom to become octet as they are forming chemical bond. So what this is saying as follows. The electron that is shared between these two atoms, this electron right here, can now be claimed by both atom A and atom B as part of the octet. So initially, before they share the electron, atom A can only claim to have one valent electron, and atom B can claim to have only one valent electron. But once they share this electron together, atom A can now say it has two valent electrons. And same thing, atom B can claim both this electron as well. So atom B can also claim to have two electrons to a part of its octets too. So that is basically the advantage of forming bonds, and how forming bonds allow the atom to get closer to an octet of electron. For an example, let's say we have water. Now, there is a reason why the chemical formula of water is H2O. So the two hydrogen for every one oxygen, not 3, not 4, or not 1, but 2 hydrogen atoms for every one oxygen atom. Let's see why that is the case. So in this case right here, based on the chemical formula, there are 2 hydrogen, and the Lewis dot symbol of each hydrogen will be as follows, with one valent electron. And now we have oxygen with 6 valent electron, and another hydrogen with another 1 valent electron. So this hydrogen have 1 valent electron, this oxygen has 6 valent electron, and this hydrogen have 1 valent electron. So right now, individually, when we look at each of these atoms individually, none of them have an octet of electron, so therefore they're not stable. So now let's see how forming chemical bond allow them to get closer to octet. So we can see that the first thing going to happen is that this hydrogen on the left and the oxygen will then take the electron that are not paired from their two orbitals and overlap them together and share those electrons. So as a consequence, this is what's going to happen. The hydrogen and the oxygen will be coming together, and now the two electrons they share between them. So that's what happened with those electrons. This electron right here are now in the middle between the hydrogen and the oxygen. And the oxygen on with this, they will have a pair of electrons right here and a pair on the bottom and one electron in this orbital that is unpaired. Now, so let's see what's happening right now as why these two atoms right here will share the electron together to form a bond. If we were to now count electrons and we go to each of this atom and ask each of this atom how many electrons that it has, this hydrogen will now can claim to have 2 valent electrons, because both of the electrons they've been shared between the hydrogen and the oxygen can be claimed by both of this atom right here to a part of the octet. Versus for the oxygen, it now can claim to have 7 valent electrons to a part of its octet. So you can see hydrogen go from 1 to 2 and oxygen go from 6 to 7 valent electrons by forming the bond between them. So this brings them much closer to octet. And in this case, this hydrogen right here, it now actually have the amount of electron they need to be happy. Because for hydrogen, it cannot have 8 valent electrons, but for it to be happy, it needs 2 valent electrons. And that it will have electron configuration similar to helium. And now, oxygen is becoming happier by forming one bond to go from 6 to 7 valent electrons. And we can see there's still another hydrogen, and another hydrogen will then come in and share its pair of electrons with the oxygen as well, and bringing those electrons together. And now the resultant structure will then be as follows. So the lone pair of electrons on the right are now being shared between the new hydrogen and the oxygen. And now let's count octet right here. This hydrogen right here can now claim to have 2 valent electrons. This hydrogen can do the same thing. It can claim to have 2 valent electrons. And now this oxygen, it can claim 1, 2, 3, 4, 5, 6, 7, 8. 8 valent electrons. So in fact, it is now having an octet of electrons. As for the hydrogen, 2 valent electrons is then referred to as a duet of electrons. And the duet for the hydrogen is similar to the octet for any other element, because that's when they have amount of electron similar to the noble gas. And whenever we have 2 electrons that are shared between 2 atoms, we can call that a bond and redraw that on a line as follows. So a line represents 2 electrons that are shared between 2 atoms to form a bond. So this pair of electrons can now be redrawn as this bond line. And then this pair of electrons can be redrawn at this bond right here. So that's what this line or this bond signifies, the electron that is shared between the 2 atoms. And now let's go over several terminology. This pair of electrons right here that share between the 2 atoms, we call this a bond pair. And a bond pair is a pair of electrons that is shared between the 2 atoms to form a bond. Versus the electron that belong to this oxygen right here, this pair of electrons belong to the oxygen by itself, but not being shared with any other atom. So therefore, we call this a lone pair. So lone pair, oxygen would then have 2 lone pair and 2 bond pair. And for hydrogen, each of the hydrogen have 1 bond pair. So that's how it would be. And in this case, again, this oxygen will have an octet of electron, and each of this hydrogen will have a duet of electron. Now the bond pair here in this case right here can also be referred to as a single bond. And now let's discuss multiple bond and single bond. So multiple bonds, double and triple bond, are referred to as multiple bond. And here's the differences between a multiple bond versus a single bond. So when one pair of electrons are shared between two atoms, they create that single bond that we have seen already. If two atoms were to share two pairs of electrons, and two pairs of electrons would then imply there are 4 electrons all total, then they create something we call a double bond. And a triple bond are then formed by the sharing of 3 pairs of electrons. Now each pair of electrons has 2 electrons, so therefore there will be 6 electrons total that will be shared between the two atoms. And that is what happened with double and triple bond. So in certain substances, we may find multiple bonds exist between them. For an example, oxygen. Oxygen is the case where we will observe the formation of a double bond between the two oxygen. And here is the explanation why. So if we were to be looking at each of the oxygen, a little dot symbol is as follows. So we can see each oxygen have 6 valence electrons individually. So they're not happy. So therefore, they will be taking the electron and share them together. So they'll be sharing the first pair of electrons and now produce the following. So each oxygen would have this shared pair right here, and along 2 lone pair and another electron that is unpaired in the other orbital. And if we were to now count the electron, each of this oxygen can now claim to have 7 valence electrons to a part of an octet of electron. So they each can claim to now have 7 valence electrons. So that's good, because by forming one bond, it can go from 6 to 7 valence electrons. And now, each of these oxygen can say, okay, well, I still have one more electron here that is not paired that I can still share. And this oxygen right here say, oh, same thing. So therefore, what they decide to do is then to take this pair and share this pair as well, and put that in the middle between the two of them. So in the end, this is what we will have: 2 pairs of electrons that are shared between the two oxygen, and each of the oxygen will then still have 1 lone pair of electron remaining. So in this case right here, this bond right here is then called the double bond. And when we draw this, we can draw this as follows. For every pair of electrons, we can redraw this as a bond line. So now there are 2 pairs being shared, so we can draw 2 of those bonds. And each of this oxygen will then still have 1 lone pair, or still have 2 lone pairs of electrons on them. And that is the structure of this molecule. And in this case, we can see this is a double bond. And now both of the oxygen have an octet of electrons. So this is the case where we see a double bond formed between the two atoms. So that way, it allows both of the atoms to have an octet of electrons. And similarly, a triple bond can also be formed as well. An example is in the case of nitrogen. In nitrogen, we would then observe the formation of a triple bond between the 2 nitrogen atoms. So here in this case right here, if we were to analyze the little dot symbol of each of the nitrogen, that's what each of them would look like. And there are 2 nitrogen. So we would then see, okay, so the first one is share this pair. And when it shared this 6 pair, this first pair right here, it'd be able to go from 5 to now 6 electrons. So that's good. And then it would then decide to share this pair as well. And when it shared this pair, it would then go from 6 to 7. And it would then also share the last pair as well. And when it shares the last pair, it now can have up to 8 electrons surrounding each of the nitrogen. So the structure that we will see as follows: nitrogen with 3 pairs of electrons between the 2 nitrogen, and each of the nitrogen will still have 1 lone pair of electrons on it. So in this case, we will then see the formation of a triple bond. So the formation of a single, double, or triple bond varies dependent on the different substances. In some substances, we may see single bond being formed, versus in other, we may see double, and versus in other, we may see triple bond being produced. And how do we figure out whether a molecule will have single, double, or triple bond? Then that is when we have to learn how to draw loose structure of molecular compound. And that would come next on the next video. And now let's do some comparison between all of this bond right here. So when it comes down to bond strength, so bond strength refers to the strength of the bond. So clearly, the more electron the two atoms would share, then the bond between the two atoms would then be much closer. So here in this case right here, with regard to bond strength, then a double bond is stronger than a single bond, and a triple bond is then stronger than a double bond. But now, as for the bond length, then the bond length is actually happening in the different direction. The more electrons two atoms share, then now the two atoms will be held very strongly together, and that will also make them come closer as well, and that reduce the bond's length. So therefore, single bond will be longer compared to double bond, and double bond will then be longer than triple bond. So that's how the trends in bond strength and bond length will be. So triple bond are the shorter, but the strongest.